Special triangles for the SAT and the ACT. Let's go. So first thing is Pythagorean theorem. We know if this is a right angle triangle, the C is the hypotenuse. So C squared equals the other two sides. Okay, A squared plus B squared, A and B the other two sides. So A squared plus B squared equals hypotenuse squared. So that is the Pythagoras theorem. Now the first special triangle we're going to talk about is what's called 30, 60, 90 degree special triangles. So in this case, you see there is the longest side, which is the hypotenuse, and it's opposite the largest angle, 90 degrees, right angle triangle. And then the smallest angle, 30 degrees, is opposite the smallest side, and the angle that's in the middle is opposite the side that is in the middle in terms of length. Okay, so if you start with the hypotenuse that's 1, then the smallest side is 1 by 2, is half of that. And then the other side is going to be root 3 by 2 times the hypotenuse. Okay, so it's root 3 by 2 is the measure of the other side. So let's take a look at one more example for the 30, 60, 90 degree triangles. Okay, so if you had your hypotenuse to be 2, so remember we said the smallest side was half the hypotenuse, so it's going to be 1, and then we said the third side, this side was going to be root 3 by 2 times the hypotenuse. So 2 times root 3 by 2, 2 and 2 cancel off, so it's just going to be root 3. Okay, so that is our examples of these 30, 60, 90 degree triangles, special triangles. All right. Next example of special triangles is what's called 45, 45, 90 degree special triangles. Here you have an isosceles right triangle. So you have 45 degrees, 45, and that's a 90 degrees. So these sides are going to be equal. So if you were to say the side is 1 and this side is going to be the same because it's an isosceles triangle, so 1 and 1. So when you do Pythagoras theorem, 1 squared plus 1 squared is 2, and then the third side hypotenuse is going to be square root of 2. So you can accordingly solve problems. If you have a side x and this is side x, this is going to be root 2x. Okay. All right, very good. So let's look at one more example of the 45, 45, 90 degree special triangle. And then if you have the hypotenuse as 1, then the other sides are going to be root 2 by 2 and root 2 by 2. They are the same in length. Now, if you were to do Pythagoras theorem, that square this and add them, you'll get to 1. Okay. All right. So next and final example of our special triangles is what are called Pythagorean triples. So these are special triangles where you have a fixed ratio of your sides 5, 4, 3, which works through Pythagoras theorem. So 5 squared is 25, 3 squared is 9, plus 4 squared is 16, 9 plus 16 is 25. So this works. That is called a Pythagorean triple. Okay, not all Pythagoras theorems have triangles have Pythagorean triples, but there are some famous ones like 5, 12, and 13, 8, 15, and 17. As soon as you see these measures, these lengths, you can immediately say that these are the Pythagorean triples. All right, hope you enjoyed this video. Let me know in the comments if you have any questions. I'll talk to you in the next video. Have a nice day. Bye.